most of the atmospheric oxygen is of biogenic origin, with only a small fraction formed as a result of photolysis. Photolysis is the decomposition of water into oxygen and hydrogen by the energy of sunlight in the upper layers of the atmosphere. It can be stated with certainty that life, which arose on Earth, gradually led to the establishment of the current composition of air envelope, which is maintained by the activity of living beings. In other words, the planet's modern atmosphere is biogenic. Quantitatively, oxygen is one of the main components of living matter. Organisms consist of 2/3 hydrogen atoms, 1/4 oxygen atoms, and 1/10 carbon atoms. Plants absorb water from the soil and, through the process of photosynthesis, create organic substances while releasing oxygen. It is plants that maintain the high oxygen content in the air. Of course, like all living beings, they use oxygen for respiration, but they consume significantly less through respiration than they release during photosynthesis. Oxygen is capable of forming a wide variety of chemical compounds, which creates numerous pathways for its circulation between the lithosphere, atmosphere, and hydrosphere. Atmospheric oxygen and that contained in numerous surface minerals are of biogenic origin. The formation of the ozone screen in the atmosphere, capable of blocking the most dangerous ultraviolet radiation, began when the oxygen concentration reached about 1% of its modern level. After this, autotrophic eukaryotes were able to develop in the upper layers of water, where solar flux was strongest, which contributed to an increase in the intensity of photosynthesis and, accordingly, an increase in oxygen output and its accumulation in the air envelope. Oxygen is necessary for the respiration of vast number of organisms. Therefore, its cycle is closely linked to the carbon cycle in the biosphere. Free oxygen, carbon dioxide, and water participate in the biological cycle. Besides photosynthesis, free oxygen is used in the processes of weathering and oxidation of rocks. The consumption of atmospheric oxygen and its replenishment by primary producers occurs quite quickly. It is estimated that a complete renewal of all atmospheric oxygen takes 2000 years.